Good morning and welcome back to today's edition of Calculus. I'm your host, Mr. Russell. Let's get back to the homework assignments. We're going to go over some of these homeworks that have been piling up. Your grades have just gone in. Some of you are doing them. Some of you aren't doing them. I'd prefer if you did them. More of you are doing them than aren't doing them. Do the whole thing. Get on the Google Meet if you don't understand. That way you don't get points off. Like on our last assignment from this homework review, a lot of you missed points because you just quit right in the middle. Come on now, be better than that. Without further ado, let's get started. So we're going to find the degree in radian measure after I finish scribbling on the paper of the angle in standard position formed by rotating the terminal side by the given amount. 1/9 of a circle. So if I'm going 1/9 of a circle, I don't need to draw it or anything. I know there are 360 degrees in a circle. Multiply that by 1/9, that gives me 360 over 9, which is 40. There's 2 pi radians in a circle, times 1/9. I'm not getting ugly with this. 2 times 1 is 2 pi over 9. And that is done. 1/24 of a circle. If you don't realize by now, 360 times 1 is 360 over 24. 24 goes into 360. Let me think of this off the top of my head. 15 times. Don't worry, that wasn't the calculator hitting my table. And then it's going to be 2 pi over 24, which is pi over 12. Number 3, 1/18 of a circle. So that's 360 times 1 over 18. 360 divided by 18 is 20 degrees. Then it's 2 pi over 18, which reduces to pi over 9. Always reduce that fraction. Don't turn it into a decimal, or we'll fight. 360 over 72. Let's see, that's going to be 5. Just confirm that on a calculadora. Yeah, I'm teaching Spanish now too. Probably doing better than Casella, I'll tell you that much. 2 pi over 72. I'm getting real bored in here in case you can't tell. That's pi over 36. So there's our first 4 done. Our next 6 are very similar. But I'll go through them anyways. Number 5, 1 over 36. 360 times 1 is 360 divided by 36 is 10. That's 10 degrees. Next one, 2 pi over 36. That reduces to pi over 18. 1/5 of a circle, do 360 times 1 over 5. 5 goes into 360 72 times. So it's 72 degrees. And it's 2 pi over 5, which can't be reduced. That's our answer. 2/3 of a circle, we do 360 times 2. Getting interesting now. That's 720 over 3. 720 divided by 3 gives me 240. Then I do 2 times 2 pi, which is 4 pi over 3. Number 8, 7/12 of a circle. Do 360 times 7/12. I'm going to show you a trick here. 12 goes into 360. I can cancel that out. 12 goes into 360 30 times. It's really just 30 times 7, which is 210. Yeah, no, I'm smart. 7 times 2 pi gives me 14 pi over 12. Yes, that's a 1. We can reduce this. It gives us 7 pi over 6. Four-fifths of a circle, I do 360. I'm just going to do 360 divided by 5 first, so I can simplify my numbers. That's 72, then 72 times 4 gives me 288. I don't believe me, so I'm going to put it in the calculator. You should do the same. But you're going to find out I'm right. Like, geniuses don't mess up. Then 2 pi times 4 gives me 8 pi over 5. Number 10, do 360 times 5 over 36. 36 goes into 360 10 times. This is just 10 times 5, which is 50. I'm going to do 2 pi times 5 over 36. That's 10 pi over 36, which will reduce to 5 pi over 18. Like a boss. Now we're on to the next assignment, which was called coterminal angles. When we look into coterminal angles, who's been scribbling on my paper? Keep your nieces and nephews off of your homework. Just playing. I didn't realize that this was going to put this on here permanently, but when I was showing someone on a Google Meet, hey, people showed up to the Google Meet. They learned stuff that day. It was nice. But it showed us exactly what we needed to do. In order to find a coterminal angle, or an angle that matches up with 40 degrees, what I need to do is I can either go clockwise, which would go negative direction, which means I subtract 360, or I can go 40 degrees and then another 360 degrees to come back to it. So that gave me negative 320 or positive 400. Negative 285 comes all the way around to here. So I could either go clockwise or I could go around a full time again. So if I do 360 minus 285, that gives me 75. And then I can either do 75 plus 360, or I could do negative 285 minus 360. Either one of those will work. So 75 plus 360, that's going to be 435. That would be a good enough answer. All right, this is our time to get some bonus points. The bonus word for the day is coterminal. So if you heard the word coterminal, send that to me in an email. That's enough of the air horn. Send that to me in an email, and you will get 2 bonus points added onto your chapter test. 2 bonus points. Let's make it 5 bonus points. 5 bonus points added onto your chapter test if you say the word coterminal in an email. Email me at my school email address, and you will get those 5 bonus points. Just checking to see if people are paying attention and actually watching the videos. There'll probably be more of those to come. Okay, negative 314. In order to find out how far I would go, do 360 minus 314. You get 46. So it's 46 degrees. I could then do 46 plus 360. They give me 406. Or I could do negative 314 minus 360. Give me negative 674. That would also work. Most of you got these ones right. 230. Do 230 plus 360. And then 230 minus 360. 230 minus 360 gives me negative 130 degrees. 230 plus 360 gives me 590 degrees. Negative 150, add 360 to that, that's going to give you 210. I could add 360 to 210, give me 570. Or I could do negative 150 minus 360. Either one would work. 285, I can just do 285 minus 360. I keep pushing 385. That's going to give me negative 75. I could also do 285 plus 360. And that's going to give me 645. Number 7, 44 degrees. I could do 44 minus 360. Gives me negative 316. And then 44 plus 360 give me 404. Now's where we get a little more complicated. If I do 405 minus 360, see, I've already gone a full revolution this time, so I can just subtract 360 to come back to my original angle. That's going to give me 45. Ooh, that's ugly. Reminds me of some people in this class. I could also add 360 to this, get 765. This one, I could add 360, get 420. Subtract 360 and get negative 300. This one, I could subtract 360. It's going to give me 170. Check my mental math here. Genius. What a genius. 170. I could add 360 to 530 and get 890 as well. I could also subtract another 360 from 170. That would give me negative 190. So all those are options. Those are fairly easy. Those should be little layups on the quizzes. All right, exercise 11 to 22, convert the given radian measure to degrees. In order to make this conversion, I just do pi over 5 times 180 over pi. Then I simplify my fraction. My pi's are going to cancel. 5 goes into 180 36 times. So it's 36 degrees. Negative pi over 6. Same thing, I'm following the same formula. 180 over pi. That cancels. Negative 180 over 6 gives me negative 30. Number 13, negative pi over 10. It's 180 over pi. 180 divided by 10 gives me 18. Negative stays, negative 18 degrees. 2 pi over 5 times 180 over pi. Pi's cancel. 180 divided by 5 is 36. Times 2 is 72 degrees. Number 23, we're just going the opposite direction now. 6 times pi over 180. And just reduce this, you get pi over 30. Negative 10 times pi over 180. That gives you negative pi over 18. Negative 12 times pi over 180. I can just reduce this. It's going to give me negative pi over 15. And 36 times pi over 180. If you do this on Desmos, you have like a fraction reducing button. You just push 36 over 180, and then it's going to do, there's going to be a little button that pops up beside your answer. You just leave the pi off of it. I'll show you how to do that right now. So if I bring up the Desmos, leave pi off of it, 36 over 180. Check this out. This little button shows up over here. I just click that. It converts to a fraction in simplified form. So you can decide whether you're going to do decimal or fraction answers on Desmos. Exercises 47 through 52. This is where a lot of people just quit doing them. It was sad, really. Made my heart hurt. Think about on a clock, 40 seconds. So how far around can it go? It can go a total of 60 seconds, right? So 40 over 60 is how far around it went. So it's really just 2/3. Then if I'm trying to find the positive radian measure of that, of the angle that it traveled, then I'm doing 2/3 times pi over 180. That's going to reduce to 90. I get pi over 270, which just doesn't seem right at all. Oh, that's because I tried to convert from degrees to radians, and that just ain't happening. No, this is bad. Let me think about that again. I was treating the 2/3 like that was a degree. What I really need to be doing is 2/3 times 2 pi. It's going to give me 4 pi over 3. That's better. Oh, all right. 50 seconds, that's 5 over 6. And then you do that times 2 pi. That gives me 10 over 6, which will reduce to 5 pi over 3. (49) is 35 seconds. So that's 35 over 60. That will reduce to 7 over 12 times 2 pi, which gives me 7 pi over 6. This last one is a little more difficult because we go around a full 2 times. So that's 120 plus 15. So that's 135 over 60. I can reduce that to 9/4 times 2 pi. It gives me 9 pi over 2. That's it for those ones. These last ones were a little easier than even those ones were. All we had to do was remember that our arc length is equal to theta times the radius. So all we're trying to do is find theta. Our arc length would be the 2 meters that has occurred, which is 200 centimeters, equals theta times the radius, which is 36. So to solve for theta, I just divide by 36. I don't know why I wrote divide by 200. You know why? Because it's a Monday morning. 200 divided by 36. That gives me 5.5 repeating. That's my theta. For this one, I'm just going to end up doing 500, because 5 meters is 500 centimeters, over 36 to find my theta. It gives me 13.8 repeating. All right, that's it for this one. It went a little long today, but that's all right.